A moment ago, we looked at a kind of random, high-performing DQN for playing the carpool game. So what if we want to set our own parameters for playing the game? How can you change around these JSON config files so that we're selecting the parameters of our choice, so that we can set up, for example, our neural network layers to be however we like? From the OpenAI Lab directory, I'm going to move into the reinforcement learning spec directory once again. Let's have a look at all of the files in there. A moment ago, we looked at classic experiment specs to find sort of default DQN agent. Let's have a look at this experiments spec file that has my name at the beginning of it. So I made this myself, obviously, and you could do the same at home. You could give the file name whatever file name you like, as long as the end of the file name is _experiment_specs.json. So this is a JSON script in here, and the highest level key represents the name of the experiment. So we're calling this the best DQN. My colleague Grant Beleveld fixed up this DQN file from one that Kang Walloon and Laura Gracer, the authors of OpenAI Lab, had created. And this is a relatively simple file here. There aren't a bunch of different agent hyperparameters that it's going to search over. There's basically one set of parameters here. There's only one kind of experiment that can be run. So let's look at the individual parameters for this best DQN agent. So first of all, we're selecting the DQN algorithm. If we had hyperparameters to test over, we'd be using grid search, so we'd just be looking at all of the hyperparameters. These other kinds of parameters like memory, we haven't really talked about, but this is related to remembering episodes and training our agent off of episodes. To learn more about any of these parameters that you're interested in, you can pop over to the OpenAI Lab page. So under Octothorpe agents-code, there are definitions for all of these various parameters. So it talks here about what options you have available. And critically, it matches parameters with each other. So depending on the agent that you choose, so if you choose the DeepQ network, for example, then there are a bunch of different policies that you can choose from. So the policies are these functions that map our set of possible states to our set of possible actions. And Kang and Laura have implemented various pairings of agents with policies. If you were to choose a different algorithm called double DeepQ learning network, then you have one of these policies to choose from. So ones like the double DQN policy don't apply to the single DQN agent, that kind of thing. It's this section here that I think is the most interesting. So it's in this parameter section here that we're defining the structure of our artificial neural network. So the theta component that in the demo that we did previously in these live lessons, we were using Keras to build dense neural network to approximate the Q star here with theta. So here, again, there are these various parameters just like we had in the Jupyter notebook that we built for our DeepQ network. So there's things like the number of hidden layers. So this means that we're going to have one hidden layer with 64 neurons in it. We're going to have a learning rate with our Atom optimizer of 0.02. We're choosing to have sigmoid activation within our hidden layers. So for example, you might want to switch that to ReLU and see how that affects how quickly the DQN agent can learn. We have gamma, which is the starting point for our discount factor, just like we said it in the Jupyter notebook that we worked with earlier. And there's decay on that gamma as well. So assuming that we have this set up as we like, we have created the best DQN, then we can use this JSON file, we can run it by backing ourselves back up to the config directory. So for me, it's located there. We can vie into the default.json, and we can change our experiment name to the best DQN. You can use any kind of tool you prefer to adapt these text files. You can just open them up with any kind of, whatever you generally use to modify, your software. I'm using Vi because, well, that's my favorite. So once the JSON is modified, then when you run grunt best again, we won't be running the default that had been set up in there before. Instead, we're running the best DQN that we set the parameters up for there. And so now we can watch that agent play the cartpool game. And given that it's the best DQN, it should perform even better. So we see the same kinds of charts and outputs. There's no point in kind of laboring over that right now. So I'm going to end that experiment. That is how we set up a model with just a single set of parameters. Up next, I'm going to show you guys how to set up a model to run where we grid search over many possible parameters.